Hello, in this segment of the course, we're going to start exploring the quantity theory of money. So the first thing that we want to talk about is the idea of the classical dichotomy, which we've already touched upon in a number of ways throughout the course. The classical dichotomy in economics separates nominal and real variables. Let's take a look. So when we look at the classical dichotomy, that tells us that we're separating nominal and real variables. When we're calculating nominal variables, as we have seen throughout the course, we measure nominal variables in monetary terms. So in other words, the price of an apple would be $2, or the price of a banana is $1. On the other hand, if we look at real variables, we talk about this in terms of physical units or in relative terms. So in other words, the price of an apple would be in relative amount of bananas that you could buy in place of that apple. So the price of an apple would be 2 bananas. If you bought 1 apple, you'd have to give up the opportunity to buy 2 bananas. On the other hand, 1 banana would cost you half of an apple. What we observe is that when we see changes in the money supply, these are going to be nominal changes. In other words, changes in the money supply are not going to have any impact on real variables because this is what we call monetary neutrality. Variables such as the money supply and price levels are nominal variables. Variables such as real GDP are real variables. So therefore, what we want to explore in this segment of the course is the relationship between nominal and real variables, specifically why when we have changes in the money supply, we're only going to see changes in the price level and not in real variables. Let's take a look. So to understand this concept of monetary neutrality and the classical dichotomy, we have to take a look at what we call the velocity of money. The velocity of money is the rate at which money changes hands in our economy. To look at the velocity of money, we have to think about the velocity of money equation, which can be symbolized as the velocity, V, is equal to the price level, P, times real GDP, which is also nominal GDP, divided by the money supply, MS. So we see that the velocity of money, the rate at which money changes hands, is going to be reflected of the nominal GDP divided by the money supply in our economy. Now, if we use just a little bit of simple algebra to manipulate this equation, we can get what we call the quantity equation. Which is going to tell us that the money supply times the velocity of money is going to be equal to the price level times real GDP. So with this equation, we're going to be able to analyze what happens when we have a change in the money supply. Which one of our variables, velocity, price level, and real GDP, is going to change in response to a change in the money supply? Let's take a look with an example. So let's suppose the nominal GDP is $10,000. Remember, our nominal GDP can be calculated as the price level times real GDP. So this is going to be equal to $10,000. Now, if our money supply is equal to 5,000, what is our velocity of money? You can take a moment to pause the video here and try to go through this calculation on your own, and then continue on with me. All right, well, let's take a look. Recall that from our velocity equation, we know that price level times real GDP divided by the money supply will give us the velocity of money. So if the nominal GDP is $10,000, or divided by the money supply of 5,000, that would tell us that our velocity of money is 2. So let's look at another example to think about the quantity theory of money. Suppose that we have the following values. Real GDP is $5,000. The velocity of money is 5. The money supply is 2,000, and the price level is 2. So using our quantity equation, we can see that the money supply times the velocity of money is equal to the price level times real GDP. So let's plug in our numbers. 2,000 times 5 is equal to 5,000 times 2. So we can see that from our quantity equation, money supply times velocity is equal to 10,000, and the nominal GDP, price level times real GDP, is 10,000. Okay, great. So now, let's suppose instead that the money supply increases to $3,000. How is each variable going to change to keep the equation in balance? So now, with a change in the money supply to $3,000, we observe that this means an increase in the money supply. So from our quantity equation, MV is equal to PY. To keep this equation in balance, either the velocity of money has to fall, the price level has to rise, or real GDP has to rise in response to the change in the money supply. Let's go through the calculations. So if the money supply increases to 3,000, what would happen? Well, now we can see from our quantity equation that it is no longer balanced. With the money supply increasing to 3,000, we see that now one part of the equation is equal to $15,000, money supply times velocity, but the nominal GDP is staying at 10,000. So they no longer equal each other. Something has to change. So let's suppose that we change real GDP to $7,500. Well, now our equation is in balance. 3,000 times 5 times 7,500 times 2 is equal to 15,000 equal to 15,000. Okay, our quantity equation is in check. But now let's think about what that would mean. A change in the money supply, again, money supply is a nominal variable. Would that influence real variables? Well, according to the classical dichotomy, we know that nominal variables are not going to influence real variables. Real GDP is a real variable. In the long run, what we observe is that real GDP and production in our economy is influenced by the number of resources that we have and the level of technology. It's not going to be influenced by nominal variables. So even though a change in the money supply from our quantity equation could be met with a change in real GDP of $7,500 to keep the quantity equation in balance. In reality, according to the classical dichotomy, real GDP would not change in response to a change in the money supply. So we know that real GDP, or Y, will not change when the money supply increases to 3,000. So now we have to go on and look at the other variables. Okay, so money supply increases to 3,000. Can we change velocity? To keep our equation in balance, if velocity goes to 3.33 instead of 5, so we see that velocity has decreased, well, now we see that our equation is in balance. So money supply times the new velocity, 3,000, times 3.33 gives us a value of 10,000. Price level and real GDP not changing, so P times Y not changing. 5,000 times 2 is giving us 10,000. Okay, so quantity equation is in check. So can we change velocity? Well, what we know from studies by economists is that in fact velocity does not change that frequently in our economy. So if there is a change in the money supply, there's no reason for us to assume that people will all of a sudden use money more, or in the sense that the transfer of money from one person to the next, or how money changes hands, the definition of velocity, would change in any way simply because the money supply increases or decreases. So we know real GDP is not going to change in response to a change in the money supply, and velocity is also not going to change simply because money supply has changed. So that leaves us with only one more option. So if the money supply increases to 3,000, we see that if the price level also increases to 3 from 2, that's going to tell us that now our quantity equation is in balance, yet again. So real GDP does not change, velocity does not change. We see a change in the money supply, which is going to be offset by a change in the price level to keep the quantity equation in balance. So what we observe here is that when there are changes in the money supply, according to the quantity theory of money, the only thing that's going to change in our quantity equation is a corresponding change in the price level. So if there's an increase in the money supply, we're going to see an offsetting increase in the price level. Therefore, we can see that monetary policy by the central bank is going to influence the price level in the economy. So what we see then, if there's a change in the money supply that leads to a change in the price level through an increase, that tells us also that price times the price level times real GDP is going to increase, since real GDP doesn't change. Remember, this is another way to calculate nominal GDP. So if there is a change in the money supply leading to an increase in the price level, we would anticipate that nominal GDP will also increase in response to this change. So what have we learned in this part of the course? Well, we've talked about the quantity theory of money, which essentially tells us that when there are changes in the money supply, we're going to see an offsetting change in the price level to keep the quantity equation in balance. If the price level is changing, this is also going to reflect the fact that nominal GDP will change, since nominal GDP is the price level times the real GDP, or Y. So this segment of the course has helped us explain how changes in the money supply or actions by the Federal Reserve through monetary policy will yet again influence our aggregate economy, specifically through their influence on the price level. As always, take a look at the textbook for more details and make sure to practice with the exercises associated with this part of the course. Thanks so much for joining me.